Hello, I'm Deborah Byrd, and you're watching EarthSky's Sun News of the Week. Our friend, Dr. C. Alex Young, is here with us. He's a heliophysicist at NASA Goddard Spaceflight Center. Hi, Alex.
Hello, how are you?
Doing awesome. How about you? Are you
I'm
doing good?
oh yeah, I'm excited to be here. I missed our last week not having it and uh definitely. And so far, knock on wood, my video setup seems better after I made some changes to my internet. So,
Oh, good. Awesome.
yeah.
Yeah, you look good. You're looking really good there. Okay. So, let's start with talking about the sun this week. And I think this image is from today, right?
Yes, it is. You can see three, or actually, it's kind of two, one of them sort of connected, two coronal holes, which are of interest because coronal holes are where the high speed solar wind comes out, which can create some space weather, not as much as coronal mass ejections, but they can uh, actually spark some aurora.
And so the things that you're calling coronal holes are just those dark areas. And what's making them look dark?
They're dark because there's less stuff there. So the magnetic fields of the sun is covered with magnetic fields. It's almost like a carpet, and the carpet kind of has little loops, and that actually holds part of the atmosphere in because the atmosphere itself is magnetic. And occasionally, those magnetic fields open up and they come back to the sun, but they make these giant loops, and so locally we call those open magnetic fields because locally they just go out into space, and that creates these kind of funnel effect, basically like a fire hose, and the fast solar wind can now escape through there, but that also means there's less solar material there, and so there's less material to glow, there's less material to give off light, and that's why they appear dark. They're not actually fully dark. It's a matter of perspective. If I were to just look on them and zoom in and change the scaling, they would still be bright. But compared to the rest of the sun, they're dark.
Wow. And this image is from GOES 16.
Correct. Yeah. So
And
goes
yeah, I want
six.
to mention that because
Yeah.
that's what we're going to be talking about later when we talk about the Solar Dynamics Observatory, whose data is unavailable right now. But this image is not a Solar Dynamics Observatory image; it's a GOES 16 image.
Yeah. So I will mention goes 16 has what's called SUVI. This is a new set of instruments. Goes now are having more and more space weather instruments, and it's very similar to SDO, but its purpose is much different in that it's not primarily designed to provide scientific data. It's designed to provide real time data of what's happening on the sun for the NOAA space weather forecasters.
Oh, okay. And so this image is another GOES SUVI image, I believe. And this is
Yes.
the M flare that just happened this morning.
Right, and this is a different wavelength. Both the image you saw before and this one are extreme ultraviolet. They show us the very hot outer corona. This particular wavelength we call 131 angstrom. That's actually the wavelength, and scientists, they know looking at them which wavelength they are. This one is especially useful for looking at solar flares because it's attuned to the very highest plasma temperatures, those that are created during a solar flare. We're talking about 10 to 20 million degrees or more Fahrenheit. The plasma is heated up, and that's why it's glowing in this particular wavelength.
And so this particular M flare, it was like an M1 point something. It was a relatively
Mhm.
small one, wasn't it?
Yes. Yes. Most of the flares we've had over the, well, actually, all of the flares we've had over the last couple of days have been small M flares. I think we may have gotten up to an M3 at one point, but otherwise they're all been very, very small M flares.
Right, and here are some of those that you're mentioning, from December 4th and 5th, a few more M flares that took place. Prior to that, in the early part of the week, we were having a bit of a lull and not at all, so many M flares. The M flares are, by the way, are the moderate flares, not as strong as the X flares, but still pretty good. So is that right, Alex? Earlier in the week, bit of a lull, and then we had this sort of
These
cluster of M flares.
Yes. Yeah, that's right. Yeah,
Okay,
earlier in the week we had only the C flares, which we now call common.
okay, and so this is another, GOES sous vide image, but what we don't have are the images from Solar Dynamics Observatory, which I think you described that as the world's premier instrument for studying the sun. So what's going on with Solar Dynamics Observatory?
Yeah, so Solar Dynamics Observatory is an instrument that's developed from a whole history of instruments, in particular, one from SOHO and especially one called Trace. And it's really, really important for us because it's the first time that we're able to look at the sun in 10 different wavelengths nearly simultaneously with a, roughly an image every 12 seconds, and these are 4K by 4K images, so they're sort of double a 4K TV. You stack two 4K TVs, and so this has provided amazing data with amazing time and spatial resolution to us to study the sun, and the world depends on this. There are other instruments like SUVI but none of them are like SDO. And unfortunately, the Joint Science Operations Center, which is where all of the data that is downloaded is then processed, is at Stanford University, and they had a pipe leak, a pipe burst in their facility, which flooded, very severely flooded the computer room where all of these computers that process the data and store the data are located. And so, as of November 26th, we do not have any new SDO data.
Wow, and so the spacecraft is fine, right?
Right. The spacecraft is fine, and we actually have not lost any data. The spacecraft downloads its data to a very unique antenna that sits at White Sands, New Mexico. That antenna was designed specifically for SDO because SDO produces so much data. It requires this very powerful downlink. All of the data is captured there and stored, but that's not the process data. That's the raw data that comes off the spacecraft.
Okay, and so the spacecraft is fine, but it's just the data, the center where they manage the data has had the flood.
Right.
Yeah,
Right.
and
We typically
so
call that the data pipeline.
the data pipeline, there you go. So the
Yeah,
pipeline's been disrupted by a pipe.
exactly. Yes, by a pipe.
Okay, and I just wanted to mention, the orbit of this spacecraft because it is in a geosynchronous orbit, so it stays above one spot on Earth.
Right. That's one of the aspects that it is designed, is put into an orbit to minimize the time to maximize the time it looks at the sun. There is no way to have a spacecraft that orbits the Earth that always looks at the sun, but you can maximize that time.
And is it SDO that has those, cool images when Earth will eclipse the sun?
Yes, that is
That's SDO?
what we call, for the spacecraft, we call that eclipse season. And yes, and that is when the Earth gets in the way of SDO. And SDO's orbit minimizes, all of these spacecraft have eclipse seasons, but SDO's is minimized to give us the most views of the sun, the most continuous view of the sun.
Yeah, and those images are very interesting too. And so as I was thinking about this morning, I was thinking, wow, I wonder if it's going to have an eclipse season while this pipeline disruption is going on. Because don't they
That's a
happen,
really
isn't January? Isn't that the next one?
They shift a little bit. They are twice a year. They last for a couple of weeks. They start off at about 20 minutes in length. They get up to almost an hour and a half, and then they go back down to 20 minutes. Um, it used to be in February and September, but they kind of shift a little bit. So it could be January. I actually have a calendar, of SDO operations, and I'll have to take a look and see
And so
when that
this
is.
Yeah, and so this data from SDO is not going to be available into early 2025, right?
Yes, yes,
That's
unfortunately, and it's also
wow.
that some of the historical data, that is the past data, is also not available. Now that's not lost. It's just that some of that data is stored at the what we call the JSOC, and that's not available. Now a lot of the data is available on other data repositories around the world. At least I know of a couple. There's one in France. There's one in Belgium. There's one at NASA Goddard Spaceflight Center. Some data is stored in a couple of different places. So a lot of the data is available, but not all of it.
And so, I noticed that the lead investigator for SDO is at NASA Goddard, and you're at NASA Goddard. Have you seen that guy, and does he look worried?
I have not seen Dean Pesnell. I have not seen Dean. I have seen Dean's deputy, Barbara Thompson, who I work with on some artificial intelligence and machine learning projects. And she has been extremely busy, extremely busy.
Yeah,
Yeah.
I bet. Yeah. I can't even imagine what must have been going through their minds when the flood occurred in that computer room. That would be that would be a freak
I
out for sure.
I can't imagine either. Yeah, I would probably have a massive panic attack if I saw something like that. So,
I bet they did, and it wasn't just SDO. There's another, spacecraft, IRIS, which was
right.
also affected by this.
Yeah, so Iris is a smaller spacecraft that was launched after. So SDO was launched in 2010. Iris was launched in 2013. Iris is a small mission called typically launched from a Pegasus rocket from they're dropped out of a plane, and similar we used to call a cruise missile. Um, and Iris is a really special spacecraft because it's studying specifically the what we call the transition region between the chromosphere and the corona. So, because one of the big questions is how does the energy, the heat and magnetic energy flow up through the chromosphere into the corona? And the chromosphere, which is for those who've ever seen a picture of or have seen a total solar eclipse in person, you see those little pink spots, which are prominences. Prominences and filaments are chromospheric material that's lifted up into the corona.
Okay,
That's why we say they're cooler.
so the chromosphere is the visible surface of the sun. Is that right?
No,
No,
the photosphere is the visible
photosphere.
surface. That's where the visible light comes from. But
Okay,
above the photosphere is the chromosphere. The
okay,
chromosphere you can see during a total solar eclipse
okay.
because it's higher up.
Okay. And so that's what this spacecraft is studying with the IRIS spacecraft.
Right.
And the
Yes.
logo that we just showed, I'll go back to that, is showing this spectrum, this rainbow array of colors. So I'm assuming that it's the interface region imaging spectrograph. So yeah, it's a spectrograph.
Yes. So it does its imaging by doing, it takes little pieces of data, and each one each part of the image actually takes a full spectrum, so you can actually see the details of the light, and then it adds those pieces up to construct an image. So now you have an image that's actually got more information if you dive into a different dimension. So here's the image, and in this direction I actually have information about the spectrum, the rainbow of light that's split up by this instrument.
Let's show an image from Iris.
Yeah,
This
so
is, to me, an amazing
this is
piece of
gorgeous.
footage.
Yeah, I love
Yeah.
this data. You can see the line in the middle. That's and you see it moving back and forth. That's because it's taking these slices. Now you'll notice all the snow. I don't know for certain, but I suspect that's probably the spacecraft passing through what we call the South Atlantic anomaly. That's probably not those are particles. Those are energetic particles. They're probably not ones from the flare. They could be, but they probably aren't. The timing doesn't make sense. They're coming before that. Um, but you see that material that's kind of flowing down. That's chromospheric material that also makes up when you see a prominence or what we call a filament. Uh, that material gets heated up, and uh, it actually heats up and rises up into the corona, and it condenses and flows back down. Those are magnetic field lines it's following. We call that coronal rain. That's
I
actually
was just going to
chromospheric
ask you.
material. Yeah. It's a
Yeah.
very, very cool effect. So if you look at it closely, you see stuff that's kind of streaming back down. So, um, but what happens here is all of a sudden there's a brightening, and then you see material coming out. So what you're seeing here is an M-class flare, an M-class solar flare, and you're seeing an eruption associated with it that created a CME. That material will continue out and turns into a CME.
Okay, but we are not going to see one of these images either for a while. So is this
Right.
one also expected to be out until 2025?
Yes, because the JSOC, the Joint Science Operations Center, also handles the iris data.
Wow.
So it does the processing for that also, and so iris will also not be available. The data itself again is fine. It's the spacecraft is fine, but the process data that we can actually look at and do science with is not going to be available.
Wow. And, I know that NASA has a large fleet of sun observing spacecraft, in part because of that sun Earth connection and how space weather can affect us here on Earth. But this is a spacecraft I'd never heard of. I had never heard of IRIS.
Yeah, iris is a very specialized mission. One of the things that's important is the chromosphere itself physically is incredibly complicated, much more complicated than some of the other regions of the sun. And so there's a lot of aspects of it that are not well understood. And so iris was designed specifically to focus on that region. And it also has required very extensive computer modeling in order to process and interpret the data because it is so complicated.
Wow. And isn't Iris the name of the minor goddess who is the rainbow goddess? Am I making that up? Am I
That's
dreaming
a good
that?
question. Well, I don't know. We should check it out. But I
I
wouldn't
think
be
it is.
surprised because yeah, this is not uncommon for scientists. NASA, of course, loves acronyms, and every
Yes.
spacecraft and every instrument has an acronym. And scientists spend time trying to come up with clever acronyms. And there's lots of clever acronyms. Very
And
clever.
this would be a clever one because this spacecraft is, carrying a spectrograph, which is splitting things
Right.
into rainbow colors. So Yeah. The reason I'm hesitating on it, I know we've written things about it at EarthSky, but the reason I'm hesitating is that when I was a kid, I used to read a lot of the Oz books by J. Frank Baum, and there was a
Mhm.
rainbow goddess in those books whose name I think
Okay.
was Iris. So
Okay.
I'm at this at this ripe old age of 73, I'm kind of not. It's like, is that a real thing or did it come from one of those books?
Well, even if
It's
it's
all jumbled up.
from yeah, even if it's from the books, and not necessarily like a, a god of some pantheon, I would not be surprised if, that does not have some association with it. I'll have to ask, the project scientist, for the NASA project scientist is at Goddard, so I'll have to ask him.
Yeah, and maybe, one of our viewers knows. So if you know, let us know.
Yeah,
Okay,
yeah,
so
absolutely.
so Iris and SDO out until at least early 2025.
Yeah, yeah. We are the solar and heliospheric community is definitely not happy with this, and we miss our SDO a lot.
I'll bet you do. And, I miss it too because I love to look at the images from it, so, well, that is all we've got for today, unless you have something else to say, Alex. I'm ready to hawk a few
I th- I
calendars.
think that's it. I think that's it for now. But we'll have some other exciting stuff to talk to. And I think personally on my social media channels on the Sun Today, I might start sharing a new daily past SDO video or something like that every day because there's
Oh,
lots of great data that's already been taken. So
oh, so come see Alex on what platforms are you on, Alex, with the Sun today?
Uh, the Sun Today is on X. It's on Blue Sky, Facebook, Instagram, Threads, and LinkedIn.
Awesome. So come see Alex in all of those places and come see him at EarthSky because he is co-author of our daily Sun post. So
Every
before
morning.
we every morning we're there, the few, the proud. Before you go, take a look at these awesome calendars. They are available at the EarthSky store. And I know that I love to give them as Christmas gifts. And they are beautiful on your wall and good for showing the moon phase for every day of the year for the year 2025. So come see us at EarthSky and pick up a calendar. And that's all we've got. Alex, thank you. And thank you so much for being with us today.
Thank you,
Don't
and I will see you in the morning.
Yeah, yes. We'll be back on Monday speaking with Teresa Constantinow, a PhD student at the University of Cambridge in the UK, about whether Venus once had oceans or not. So join us on Monday for that discussion. One Earth, one sky, Earth.